In this video, we discuss Learning Outcome 4, which is all about constructing and interpreting box plots and modified box plots for given data sets. Remember, we talked about that 5-number summary in the last video. The 5-number summary consists of these 5 values. Basically, you've got your maximum and minimum value, and then you've got your first quartile, second quartile, and third quartile. Now, these 5 numbers show us the range of values, but they also show us how those values are distributed. We know that the first 25% of values in our data set lie between the minimum and that first quartile. And then the next 25% of values lie between that first quartile and the second quartile. The next 25% lie between the second quartile, which is the same as the 50th percentile, and the third quartile, which is the same as the 75th percentile. And then the last 25% lie between the third quartile and the maximum value. A box plot, otherwise known as a box-and-whisker diagram, is a graph of that 5-number summary. Basically, it consists of a line extending from the minimum value on our list to the maximum value on our list. And then it has a box with lines drawn at the 25th percentile or Q1, the 50th percentile or Q2, and that 75th percentile or Q3. So we've got a little box in the middle that is basically showing us that middle 50% of our data. And then we've got a line extending beyond that that shows us the rest of our data. So this is just a visualization of that 5-number summary. The reason we do this is because it displays the spread of the data. We can see how that data is grouped when we look at the box plot. It also displays the distribution of data in much the same way that a histogram would. And that makes it excellent for comparing data sets. So here's our procedure for constructing a box plot. First, you find the 5-number summary, and then you construct a line segment extending from the minimum to the maximum. And then you draw a rectangle extending from Q1 to Q3, and then draw a line in the middle of that rectangle at Q2. And let's do that for a particular data set. So we've got the Verizon Airport data speeds, and we want to use it to construct a box plot. Now remember what we did last time in that last video. We found a 5-number summary for this data. We've already done it. So the 5-number summary is 0.8, that's our minimum. 7.9 was our first quartile or 25th percentile. 13.9 was our 50th percentile or second quartile. It's also the median. Then we've got our 75th percentile, which is the third quartile at 25 or 21.5, excuse me, and the maximum was 77.8. All of these are in units of megabits per second. So if I want to graph these, this is what it would look like. Now you might think that it looks a little odd because all of these regions, these differences between that minimum value and Q1 and this Q3 and the maximum value, they're all just a little bit different, and that's intentional. So this is showing us how that data is distributed. It's showing us that 25% of our data lies between this 0.8 and 7.9. So that means there's a difference of about 7 units between that first quartile and the minimum. But then look at the third quartile and the maximum. So there's a difference of about 56 megabits per second between that maximum value and that third quartile. So this is showing us where that 25% in each little piece, it's showing us where that 25% actually lies. It shows us how spread out it is or how condensed it is in terms of how close those values actually are to each other. So that minimum of 0.8 and that first quartile of 7.9 is about 7 units apart. That 7.9 and that 13.9, that's 6 units apart. And then the 13.9 and the 21.5, well, that's about 21 and that's about 14, so that's about 7 units apart. But then we've got this huge gap between the 75th percentile or the third quartile and the maximum. So this shows us that distribution. We can see that this 25th percentile covers a large range of values. So if we were to look at a histogram for the same data, what we would see is we would see a graph with a really long right tail. So this is actually showing us that our data is skewed, and it's skewed to the right because we have this really long line segment starting at Q3 and ending at the maximum. So that's one of the ways in which this Boxplot, is insightful. So I just mentioned skewness. We can use Boxplots to identify skewness. We say that a distribution of data, is skewed if it's not symmetric and extends to more to one side than another. And of course, I was just talking about this data set as visualized by this box plot. It's skewed to the right because we've got that long right tail. Here's another one. We've got heights of random sample of women. It looks like from the box plot, we can see the minimum value in the data set is 59.1. The first quartile is at 61.5. The second quartile, that splits the top half from the bottom half of the data, that is at 63.3. The 75th quartile is 64.95. I bet these are in inches. And then that maximum height in our sample was 67.8 inches. The question for you is, does the data seem to be normally distributed? Remember what we're looking for with normally distributed data. We're looking for symmetry about some center point. We should see rough symmetry on the left and the right. You can see that symmetry in the box plot. So this is very symmetric about that 63.3 in the middle. So I would assume that the heights of women are normally distributed based on the box plot. Here's one for salaries in thousands of dollars of football coaches. So it looks like in our data set, we have a minimum salary of $125,000. The first quartile is at $205,000. So that means the lowest paid football coaches, that bottom 25%, they have salaries between $125,000 and $205,000. Then the next 25%, so it's the 25th percentile to the 50th percentile, have salaries between $205,000 and $300,000. And then the next 25% have salaries between $300,000 and $638,000 approximately. And then look at that long right tail again. We've got data skewed to the right. There are some football coaches, or there's at least one football coach in our data set that has a salary of $2,840,000. So what is that? That's $2,840,000 approximately. So from this data set, we can see that this is skewed to the right. Most football coaches have salaries down here, but there are some that have very, very high salaries. And that's shown when we look at the box plot. Even if we can't see all of the data, these 5 summary numbers tell us a lot. And these 5 summary numbers listed in a table would tell us something, but somehow showing it on a graph like this gives you a much better sense of the distribution of the data than if we were to see those 5 numbers listed in a table. Now there are also box plots that are modified. We call them modified box plots, and they're constructed just a little differently. We still have to find those 3 quartiles, that 25th percentile, the 50th percentile, and the 75th percentile. And then we do something else. We compute what's called the interquartile range. This is the range between that 25th percentile and that 75th percentile. So we compute the difference between those 2 values. And then we say, okay, whatever that difference is, multiply it by 1.5. And then we're going to say, any value is an outlier if it is above Q3 by by an amount greater than 1.5 times that interquartile range. Or if it's below Q1 by an amount greater than 1.5 times the interquartile range. So rather than graphing the minimum in these modified box plots, we graph Q1 minus 1.5 times the interquartile range instead of the minimum. And then rather than graphing the maximum, we graph Q3 plus 1.5 times the interquartile range. And we're going to say every value from this lowest one to this highest one, we're going to say those are sort of normal values. We're going to call those, I wouldn't say that they're typical. They might be significantly high or significantly low using the range rule of thumb that we've talked about previously. But we're going to say any value in that range is not an outlier. But anything beyond that, anything lower than this value or higher than this value is going to be classified as an outlier for our purposes. So our horizontal line, rather than going from the min to the max, is going from this value to this value. And then if you have outliers beyond that, points will be plotted or asterisks will be plotted to identify those outliers. Now, for the most part, you are not going to be constructing modified box plots, but I would like you to be able to interpret them and understand them. So here is a modified box plot for the pulse rates of females, and it's using this table 2.1.1 from an older edition of our textbook with all of those pulse rates. Now, this is the box plot for the pulse rates of females, but notice that it's modified. We've got two outliers. It looks like one is above 100 and one is, or two are above 100. One is just a little bit above 100 and the other one's above 120. If we look at our data set, you've got one pulse rate of 104, so that's that one, and one pulse rate of 124, so that's that one. So you have two very extreme values. And we're going to call all the rest of the values non-outliers, just typical values. And they are shown by this box plot, this modified box plot over here. Now, if you calculate a Q1 minus the interquartile range, which is this difference between Q3 and Q1, which happens to be 12. If you calculate that, it's actually lower than the minimum value. So we're not going from Q1 minus 1.5 times the interquartile range in this case, because the minimum value is actually higher than that. So we're going from the minimum to that first quartile. Then this bar indicates the second quartile, or the 50th percentile, or the median, same thing. Then this bar indicates that 75th percentile or third quartile. And then this one doesn't go all the way to the maximum value, which would have gone all the way over here in a regular box plot. It only goes from Q3 up to Q3 plus 1.5 times the interquartile range. And we're saying most of our values are there, but we've got a couple of extra values. We're going to call those outliers. One is that 104 and the other one is that 124. So if you see something that looks like this, or maybe instead of a dot here or a point plotted, they've got an asterisk, that's a modified box plot. And that is identifying outliers in this very specific way. Before, we were just saying that outliers were numbers that were very far from all the other values, very high or very low. And you might say, like, what do you mean by very high? Or what do you mean by very low? This modified box plot gives us a definition of very high or very low. It's anything beyond that Q3 plus 1.5 times the interquartile range. So values that are above that, and anything below that Q1 minus 1.5 times the interquartile range. So that's a box plot. Those are box plots. And remember, we start with that 5-number summary, and then we graph accordingly. And these box plots will allow us to see some sense of the spread of the data and the distribution of the data, which makes it a really handy way to compare data sets.